Welcome to my channel Easy Way of Learning Chemistry. Today we are going to learn electrolysis. In electrolysis we are going to learn some important terms. Most of you will confuse with some important terms cathode, anode and all. Today I am going to clear about it. The first term is cation. Cation is formed by the type of metal, the type of element is metals. So it forms positive charge. Example, Na plus. Cation formed by a metals and it produces positive charge. Example, Na plus. Next term is anion. Anion is formed by the type of element non-metals. So it produces negative charge. Example, Cl minus. So Na plus is the example for cation, Cl minus is anion. Next, cathode. Cathode is the electrode which is connected to the negative terminal of the battery in the electrolysis. Anode is connected to the positive terminal of the battery. Cathode is negative charge and the anode is positive charge. Cation migrate towards cathode. Cation migrate towards cathode because cation is positive charge and the cathode is negative charge. So to remember easily, both also cat. First three letter is cat. Cation migrate towards cathode and they are opposite charge. Anion migrate towards anode. Anion is negative charge and anode is positive charge. Anion migrate towards anode because both also opposite charge. To understand this, you can remember the first two letter. The first two letter is the same. Anion migrate towards anode. So you may confuse with the term cation, cathode, anion, anode, which is positive, which is negative. So I will give you a small tip to remember the charge of cation, cathode, anion, anode. So if you are confusing, you must write this order: cation, cathode, anion, anode. So in that, first you remember the cation, about cation. So normally we will think that positive negative only. We won't think that negative positive, isn't it? So the first one is cation. You just think that positive. By using the cation positive, you can write all the charge of cathode, anion, anode. How? Cation and cathode is opposite charge, isn't it? Yes. Cation and anion is opposite charge. Anion and anode is opposite charge. Cation charge is positive, so cathode charge is negative. Cation charge is positive, so anion charge is negative. Cation charge is positive, anode charge also positive. Is it clear? Yes. Now you have no confusion in that cation is positive, anion is negative. Cation and anion are opposite charge. Cation is positive, anion is negative. Cation migrate towards cathode. So in the cathode, it will be deposited. Anion migrate towards anode and there it will be deposit or evolved. If there is more than one ions, how it will discharge? Anyway, only one ion only will be discharged. So there is a competition between the ions. So that if we use this electrochemical series, we come to know that which ion will discharge. So which ion will present in the down of the activity series, it will be discharged. Let us learn the electrolysis of molten lead bromide. So in this molten lead bromide, we have taken the lead bromide in the molten state in the silica crucible. So there are only two ions, Pb2 plus and Br minus. There will be no the water molecule, water ions. Why means we didn't add any water. It is an electrolysis of molten lead bromide, Pb2 plus and Br minus. So there is no competition here. The positive ion will move to the negative electrode. Negative ion will move to the positive electrode. So cathode reaction, there is only one ion will go to the cathode, that is Pb2 plus. So cathode is negative, Pb2 plus is positive. So Pb2 plus will gain 2 electron. It produces Pb, and the color is grayish color of lead is deposited. In anode, Br minus is moving, and the Br minus, it will lose 1 electron and it becomes Br. As it is a diatomic element, it combined to form bromine molecule. So the observation is reddish brown, bromine is evolved. So in this molten lead bromide, we have to remember some important points. The first one is silica crucible is used because it can withstand high temperature. So we use the silica crucible. Second one, solid lead bromide cannot be used instead of molten lead bromide. If you use solid lead bromide, the ions are very tightly packed and there is a strong force of attraction. So there is no free mobile ions. So we use the molten lead bromide. Next point is graphite anode is preferred. We choose the graphite anode because it is unaffected by the bromine vapors. So bromine vapors are evolved at the anode, isn't it? If there is active electrode, it will be reacting with that. So we are using the graphite anode. So we are preferring the graphite anode. Okay children, I hope you all understand. If you understand this topic, you subscribe my channel, you like and share to all your friends. I'll see you with the next video. Bye.